Friends and friends, welcome to my YouTube channels. Today I am going to solve some new problems that beam the given inclined load, and they're asking find the shear force and bending moment diagram, and one new thing they're asking also find the thrust diagram or axial force diagram. Thrust diagram or axial force diagram. So axial force diagram and thrust diagram before I not solved because up to this shear force and bending moment diagram we draw. But once inclined load the given in the on the beam, then only thrust diagram or axial force diagram will exist. So how to solve this? So in once inclined force will be there now, you know the inclined force having two component. So first we have to draw the new load diagram. So first inclined load now how to resolve the forces. You see here one technique. Suppose this force is like this is there. What is 160 degree? 60 degree. Then how to resolve? So resolutions will be there. This is the inclined force. So resolve will be with respect to horizontal draw one line. With respect to horizontal draw one line and mutually perpendicular line. This is the resolution of forces. See, with respect to horizontal and draw the perpendicular line. So this angle is how much? This angle is 60. So this angle also will be 60 because this given angle is 60 here. Now like this will be there alternating. This angle 60 now this angle also will be 60. So here this angle is given 60. They given 60. So this angle will be 60. So how to resolve now? We have inclined force having two components, horizontal and vertical. So this is horizontal, what will come? 100 cos 60 and this is 100 sin 60. Horizontal component, horizontal forces always cos component will be there and vertical having sin component. So this way we can find the all the forces, vertical and horizontal forces. So this is the trick for the inclined force, how to resolve the two component, because horizontal force having single component, vertical force having single component, because here theta is equal to 0 degree, here theta is equal to 90 degree. So cos, see this cos 0 1. So horizontal force having only vertical component. Horizontal force, what is cos theta will be 0 no 1. So horizontal force only will exist, but vertical sin 90 0. So vertical will exist only. So horizontal forces, vertical component will be 0. Vertical forces, horizontal component will be 0. But inclined forces having two components, both sin and cos. Because sin 0 degree 0 and cos 0 degree 1. Suppose sin 0 degree 0, cos 0 degree is 1. So sin 91, cos 90 0. So value sin and cos value varies from the 1 to 0. So that's why inclined force means theta is equal to greater than 0 and less than 90. That's called inclined force. Once theta will be 0 horizontal, theta will be 90 vertical. If theta will be between 0 and 90, all are the inclined force. So inclined force having two components. So this way we can resolve and find the horizontal and vertical forces. So all forces I calculated like 100 cos 60, this coming 50, this coming 50 Newton, and vertical it is coming 86.6 Newton, 86.6 Newton. Similarly, 200 cos 45, both will come, and sin 45, both will come same only. 141.4 Newton, this also will come 141.4 Newton. Then 300 cos 30, 300 sin 30. So this is coming 150 Newton and this is coming 259.8 Newton. So this first work what we did, we inclined force the given, we resolve this, and two component we wrote horizontal and vertical. So and hinge support, this is roller support. Roller support only having one reaction, vertical reaction, but hinge support having horizontal and vertical reaction. So what I given at point A, this is point A This is point A, this is point C, this is point D, this point E, this point B. So A point RAB, vertical force, RAH, horizontal force. So hinge support having two component, two reactions. Hinge support having two reactions and roller having only vertical reaction. So I given. So this is the concept here up to this draw. Now we'll find the reaction forces. Now we'll find the reaction forces. So first work what we did, we resolved the forces and wrote the horizontal and vertical forces. So now what is the equilibrium equations? Because we have to find out the RAH, RAB and RB. So equilibrium equations, first we'll take the summation FH equal to 0. That means total leftward force equal to total rightward force. What is there here? We assume this because all are coming this direction. So this will be definitely this direction. If we will see these directions, all forces, beam will be not balanced. So all forces, all are same, inclined in same direction. So all forces coming towards the left. Now this force what is RAH equal to 50 plus 141.4 plus 259.8. So total coming how much? This total I wrote 451.20. 451.20 Newton. RA plus the RAH is equal to. Okay. So now we'll take the another equilibrium equation sigma V equal to 0. That means total vertical forces will be 0. So here what will concept will follow? Total upward force is equal to total downward force. So what is upward force? RAV plus RB is equal to 86.6 plus 141.4 plus 150. So this will come, once we'll add, this will come 378. So 378 Newton. All are given Newton, so will be the Newton only. Now if we'll substitute this equation RA plus R, okay, this came. Now come the third equilibrium equation, moment about A will take 0. That means total clockwise moment is equal to total anti-clockwise moment will consider. So taking moment about A, so this will come clockwise direction. This will come clockwise direction. Due to this will come also, this is clockwise, you write clockwise direction. This also will rotate clockwise. This one, another, this will rotate ACW, anti-clockwise direction. This will rotate anti-clockwise direction. So total clockwise is equal to anti-clockwise. So what we'll write here? 86.6. So force into perpendicular distance. This distance is 1, 1, 1, 1. So force into perpendicular distance is nothing but moment. About A, force clockwise, force into perpendicular distance 1. So into 1. Then plus 141.4 into total distance is 1 plus 1, 2 plus 150 into 1 plus 2 plus 3. Distance is 3. Then anti-clockwise RB into 4. Total distance is 4. So this way we can get RB. So RB will get here this total how much? Total is coming 819.4 divided by 4 is equal to is coming 204.85. 204.85 Newton. Now if you substitute, suppose this you give equations number 1 here. Substitute this RB in equation 1. So we'll get the RAV. RAV how much you'll get? 378 minus 204.8. 378.2, so 173.15. 173.15. So we got here what is RAV 173.15 Newton, and RB we got, RB, where is RB? 204. So 204.85 Newton. We know this. So support reactions we calculated. If sometimes they will ask what is the, so many full questions they will give, and they will ask what is the support reactions at B, what is the support reactions of A, like this. Some questions, objective questions will be there. Okay, and they'll ask what is the shear force at point D, what is moment, bending moment at point E, like this. Various objective questions, competitive exams they will give. So if you know the full set, the set solution, so whatever in between they will ask objective question, that also we can say. Suppose any competitive exam, GATE exam, you will see, na, they will ask this same question they will give, and only they will ask what is the support reactions at B. So up to this you have to come. Or what is the shear force at point E, what is the bending moment at point C, like this. Some questions, 2-3 questions they will give, and they will ask the choice. So if you know the full solutions, we can solve like these questions also. So support reactions over. Now our work is find the shear force diagram. So shear force diagram we will draw. First we will draw the shear force zero line. So we will draw the zero line shear force diagram. So then we will do the shear force calculation, and we'll one by one will substitute everything. So this is the shear force diagram, zero line. So we'll do the shear force diagram calculation. So what is the sign conventions will follow here? See here. If we'll take the section, if we'll go the right side downward, upward is left side is upward, will be positive. Then opposite, if we'll take this upward, this will take downward, it will be negative. This is the sign conventions we will obey here. Left side and right side. Okay, now SA. I am taking shear force na S at point A is equal to how much? Vertical 173.15 Newton. Shear force at A is equal to this. Suppose we draw later. Now at point C. So at point C, here if we will draw between A and C no load. But what we will do now, we are taking from left side. So if we will write here SCL, that means this point load will not come here, just before this C point. So same things will come. What is 173.15? Why I am drawing like this? For the understanding. See here. Suppose we will take the A. How much? 173. Now at point C, just before, that means L. SCL means 173.5. If you write here SCR, that means just will consider this point load. SCL means we are not considering point load. So in between we know A and C, no load. In between A and C, no load. Now load acting R. So what will be there? Up to this you write 173.15. Now downward force. Downward force left side negative. So minus 86.6. So how much coming this? We calculated already. 86.6, 86.55. 86.55 Newton. So now what we will do here? We will draw this diagram 86.55. So it will come here. Up to this we draw here. 86.55. Now we will go the SD. Similarly here same things we'll do here. SDL will go. SDL means no load in between. So same point will be there. What is 86.55 Newton. Now if you go SDR, that means this point 141 point acting. So same things. What is here? 86.55 minus 141.4. This value how much coming? 186.55. So it is coming minus 54.85. So now look here. So this will be same up to 86. 86. Now this SDR, due to this force, how much coming? Negative coming 54. So it will go this downward direction. So here D, this will come 86.55. Then this is coming how much? 54.85. 54.85. We got this. Okay. Now SEL. Again, what we'll do now? SEL will take. SEL means just before this E point. So same things will come how much? Minus 54.85. This way if you'll do now, it will get clear concept. Why between A and C no load? So here see, same thing I am writing. Similarly here up to E. So we'll draw this line, no load in between. Up to this point, no load. Extend all those things, lines and all. So in between, no load. Now SER. If SER will see, what will be there? Minus 54.85, then minus, because downward force is there. Downward force is negative. So 150. 150. This is coming 204.85. 204.85. So this will come minus 204.85. So it will come down here and up to this no load. So similarly here what we'll write? SB now, no? So SBL if you'll write, SBL will write minus 204.85. But again if you'll write here SBR, it will come 0. Okay, I will write one more instance. SBR, what will come? Minus 204.85 plus will come. Because upward force, left side we are taking 204.85 plus 204.85 equal to 0. So now we'll join this. So this way we know the shear force diagram. This way we know the shear force diagram. Now where is the shear force diagram? Just you have this line. These are the positive part. From here this is coming negative. This is coming negative. So this way we can do the shear force diagram. Okay, this value how much coming? 204. 204.85. 204.85. 204. So this way we can draw the shear force diagram. Now we have to draw the bending moment diagram. Then finally we'll draw the thrust diagram. So up to shear force diagrams over. So these things already before also lot of video I given. So if you'll see the previous video and all, same concept I did everywhere. So up to this nothing new for you. So now we'll draw the bending moment diagram. So we'll take this space from top. Bending moment diagram we'll draw now. So bending moment diagram. Bending moment diagram at A, at B will be 0. So bending moment diagram calculation. If we'll see bending moment at A will be 0, bending moment at B will be 0, because if we'll take moment about A, force passing through the same point, so 0. Again bending moment B, 0. Now we have to find C, D and E. Bending moment at C, bending moment at D and E. So first sign conventions what will follow here. This is the section. If we'll see the clockwise for right side, it will be negative. If we'll take left side, clockwise, anti-clockwise, ACW will be the negative. Reverse. This is anti-clockwise, now this is clockwise. this is anti-clockwise, this will be positive, this will be positive. This the sign conventions will follow. So I am taking from the left side. So C, bending moment at C, RA into 1. Bending moment at C, MC, equal to RA. RA how much? 173.15 into 1. Because taking moment about C. So what will come here? RA. It RA going clockwise. See? RA going clockwise. Clockwise left side will be positive. So 173.15 into 1. So it will come 173.15 Newton meter. Now we'll draw this the zero moment line, and all the points will draw, and we'll draw the bending moment diagram. So okay, so we got now MC over, then MD this point. So again RA 173.15 into 2, because total distance is 2, going clockwise is positive, from left side clockwise positive, so 173. Now this coming anti-clockwise negative 86, this is called minus 86.6 into, because we are taking moment out D, so this distance is 1, so it will be 1. So if we will calculate this, where we will calculate this MD, it will come 259.7 Newton meter. So we got the MD here. Now ME this. So from there RA is clockwise positive 173, 123, distance is 3 meter, 173, 1.53 minus 86, this distance is 2, so 86.6 into 2 minus again 141.4 into this distance is 1. So this way we know the bending moment at E. Bending moment at E is coming 204.85 Newton meter. 85 Newton meter, bending moment at E over. So now we'll draw the diagram. A and B. This is point A, this point B, bending moment will be 0. Now because having point load na shear force diagram is horizontal line, this will be the inclined line, bending moment will be the inclined line. First how much? 173. So this will draw here. This point is C. Now MD, this is the point D, so it will be how much? 259. So little top, this also inclined line. Now 204, it will go 204. So here it will be 204. Then here will come 0. So join these two lines, it will come 0. So this point is D, this point is E, this point is B. So this way we can draw the bending moment diagram. See, so you can write this value here. Here value will be 173, space will be there na 173.15. Here D point, here value you write 259.7, here value you write 204.85 Newton meter. Everywhere will be the same units. So this way we know the bending moment diagram. So okay, now we'll draw the thrust diagram. So that is the important. Thrust diagrams only will come into the horizontal line only. If inclined force is given, then only thrust diagram will exist. So these things we'll rub it now, and we'll draw the thrust diagram and thrust diagram calculation. So okay, so thrust diagram calculation. So thrust diagrams when will exist, if inclined load will be there on the beam, then only thrust diagram will be exist. So okay, so thrust diagram at A. So thrust diagram will write TH, thrust diagram at A, TH, thrust diagram at A. How much? Horizontal, so 173. So here also we'll take, this side will take positive, and if we'll take from opposite, this will take the negative. So thrust diagrams we are taking from the point A. How much? Horizontal force RAH. RAH I not wrote, no? RAH, how much we got? RAH we got 451. So we'll write here 451.20. 451.20. So it will write here 451.20 Newton. Thrust force will be 4.2 Newton. So okay, now thrust force at C. So TH, thrust force TC. T, because thrust force I notations I given H, T, thrust force T, H horizontal at A. Now TC na, TH, okay, horizontals will write everywhere. THC, thrust force at C. How much? 451.20 minus how much? 50. Minus 50. So it will come 401.2. 401.2 Newton. Now thrust force at D. So T, because horizontal I am writing, because thrust force exists only horizontal. So that's why I write now D. So D how much will come? 401 up to this coming now. 401 this coming up to 401.2 minus how much is there? 141. 141.4. So this is coming 259.8. 259.8 Newton. Thrust force at D. Now we'll find the thrust force at E. Thrust force at E is equal to 259.8. 259.8 and how much there? 259.8. So it is coming thrust force at point coming 0, because here no horizontal force, so thrust force will come up to this point only. So thrust force will come up to this point only. So we'll draw the thrust force diagram here. First we'll draw the line, extend this line. So calculations parts over. Now we have to draw. So this is the additional, before what video I given, this is the additional. They're asking what is the thrust force. So we'll draw first thrust force line, that is called also zero line, because in this line thrust force will be 0. Now first will be how much? 451. So we'll draw this line here, 451. So up to there will be same. Now thrust force at C. Thrust force at C coming. So it will come thrust force at C coming 401. So okay, now thrust force at coming 259. Thrust force is coming 259 at E. So okay, what little higher drawn, it will be looks. We'll go the different colors now. It will be easy for you. Thrust diagram will go the different color. Now this. Now just 401. So here we'll draw the 401. Again here is coming how much? For 259. It will come down, then it will go 259, and E point you are seeing the 0. So this is the thrust force line. So we'll write this value here. First, what is 451.2. Here will come 401.2. Here will come 259.8. So this is point is A, this is B, this is C, this is D, this is E. Here thrust force will be, because no horizontal force, so thrust force line will be up to there only. So this is the new things, additional what we did now. Previous video up to shear force and bending moment we drawed. If they'll ask find the thrust force, if they'll ask find the thrust diagram, this is bending moment diagram, this is shear force diagram, this is the load diagram. So this way we can solve the question like this. Whatever question will come, if they are asking the thrust diagram, you should see inclined line. Either inclined line they will give same directions, or maybe will give the different directions. So we can calculate. Okay students, watch the video, share this video to your friends so they can get benefited. Okay, thank you.